Tonight, at some point, you're going to stop everything. You'll close your eyes, lose consciousness, and spend roughly a third of your entire life doing absolutely nothing. You won't remember most of it. You won't produce anything during it. And if someone offered to give that time back to you, permanently, most people's first instinct would be to say yes. So what would actually happen if you did? What if you never had to sleep again? The answer is not what you'd expect. And it reveals something about sleep that most people never stop to consider. Something that changes the entire way you think about what your brain actually is. Let's start with what sleep deprivation does to a human being, because the science here is some of the most disturbing in all of biology. In 1964, a 17-year-old high school student named Randy Gardner decided to stay awake for as long as possible for a science fair project. He lasted 11 days and 25 minutes, a record that still stands as the longest scientifically documented case of voluntary sleep deprivation in history. Sleep researcher William Dement of Stanford University monitored him throughout. By day 4, Gardner was hallucinating. He mistook a street sign for a person. He believed he was a famous football player. By day 6, his speech had slowed. His memory was fragmenting. His emotional responses had become completely unpredictable. By day 10, his cognitive performance on simple tasks had degraded to the point where he could barely complete a sentence. And all of this from a 17-year-old in otherwise perfect health. Gardner recovered fully after sleeping, but his case established something critical. Sleep deprivation doesn't just make you tired. It dismantles the architecture of your mind systematically, in a specific sequence, and faster than almost any other form of physical stress. But here is where the question gets darker. Because Gardner survived, what if the deprivation never ended? There is a rare genetic condition called fatal familial insomnia, first documented in detail by neurologist Ignacio Reuter and extensively studied by researcher Pierluigi Gambetti at Case Western Reserve University. It affects an extraordinarily small number of families worldwide, caused by a misfolded prion protein that progressively destroys the thalamus, the region of the brain that regulates sleep. People with fatal familial insomnia stop being able to sleep, not partially, completely. They enter a state of permanent, inescapable wakefulness. Within months, they develop dementia, lose the ability to walk, and lose the ability to speak. The average survival time after the onset of total insomnia is 12 months. There is no treatment, there is no recovery. Every documented case has ended in death, caused not by any external disease, but simply by the inability to sleep. This single condition answers the central question more definitively than any thought experiment could. You cannot survive without sleep, not long term, not even close. The question isn't really whether a human could live without sleep. The question is why sleep is so catastrophically necessary that its absence kills you faster than starvation. And the answer to that question is one of the most fascinating unsolved problems in all of neuroscience. For most of the 20th century, scientists assumed sleep was primarily about rest. The body needed to power down, conserve energy, repair tissue. This made intuitive sense. It was also, it turns out, mostly wrong. In 2013, a research team led by Maiken Nedergaard at the University of Rochester published a landmark study in the journal Science that fundamentally changed how neuroscientists think about sleep. Nedergaard's team discovered that the brain has its own waste clearance system called the glymphatic system, which operates almost exclusively during sleep. During waking hours, your neurons are firing constantly, burning energy, and producing metabolic waste products as a byproduct. One of those waste products is a protein called beta amyloid. You've heard of it. Beta amyloid plaques in the brain are the defining physical characteristic of Alzheimer's disease. During sleep, the brain's glymphatic system activates. Cerebrospinal fluid floods through channels in the brain, washing out accumulated beta amyloid and other toxic proteins at a rate roughly 10 times higher than during wakefulness. Your brain, every single night, is cleaning itself. And if you skip that cleaning, the waste accumulates. Nedergaard's research demonstrated a direct measurable link between sleep deprivation and beta amyloid buildup in the brain. This is not a theory. This is a mechanism. Every night you don't sleep enough, you are leaving your brain slightly less clean than it was before. Do that for years, and the math becomes deeply uncomfortable. So if you never slept again, here is what would actually happen, laid out honestly. Within the first 24 hours, your cortisol levels would spike dramatically. Your immune system would begin to suppress. Your ability to consolidate new memories would start to collapse, because memory consolidation, the process by which short-term experiences are transferred into long-term storage, happens almost entirely during sleep, specifically during the slow wave and REM stages. Within 72 hours, hallucinations would begin. Not mild distortions, full sensory experiences indistinguishable from reality. Your emotional regulation would break down completely. The prefrontal cortex, the part of your brain responsible for rational decision-making, impulse control, and social judgment, would begin to go functionally offline. The amygdala, the brain's threat detection center, would become hyperactive and completely unregulated. You would become, in a measurable neurological sense, a different person. Impulsive, paranoid, emotionally volatile, disconnected from reality. Within weeks, based on what fatal familial insomnia tells us, your body would begin to fail at a systemic level. Organ function would deteriorate. Your immune system, already suppressed, would lose the ability to respond effectively to infection. And your brain, without its nightly cleaning cycle, would begin accumulating damage it could not reverse. You would not survive. But here is the part of this question that almost nobody asks, and it's the part that matters most. If you were somehow given a version of yourself that never needed sleep, you would not simply gain 8 extra hours per day. You would gain something far more significant. Sleep, for all its biological necessity, is the state in which your brain is most completely offline from the external world. It is the only time in the entire 24-hour cycle where your mind turns genuinely inward, where memories are reorganized, where emotional experiences are processed and filed, where the noise of the day goes quiet long enough for something deeper to surface. Neuroscientist Matthew Walker, author of extensive research on sleep at the University of California, Berkeley, has argued that REM sleep in particular functions as a kind of overnight therapy, a state in which the emotional charge of difficult experiences is stripped away while the memory of the experience itself is preserved. People who sleep after a traumatic or distressing experience consistently remember it better, but feel it less intensely than people who are kept awake. Sleep doesn't just clean your brain, it regulates your relationship with your own past. A version of you that never slept would never have that processing window. Every difficult experience would arrive raw and stay raw. Every stressful day would stack directly on top of the previous one, without the nightly reset that allows you to wake up and feel, however imperfectly, that it's a new day. The real answer to the question is this: you don't sleep because your body is weak. You sleep because your brain is doing something during those hours that it cannot do any other time. Something so essential that evolution, across hundreds of millions of years, never found a way around it. Every animal with a brain sleeps. Every single one. Fruit flies sleep. Jellyfish sleep. C. elegans, a worm with exactly 302 neurons, sleeps. Whatever sleep is doing, it is doing something so fundamental to the architecture of a nervous system that life never evolved past the need for it. We built alarm clocks to fight it. We built artificial light to delay it. We built a culture that treats needing 8 hours as a character flaw and surviving on 5 as a badge of productivity. And every morning, the brain quietly pays the price, one night at a time, one layer of uncleaned waste at a time, until the bill comes due in ways we spend decades attributing to anything except the most obvious cause. You will sleep tonight, not because you're tired, because your brain will simply stop giving you a choice.